Questions about ancestry testing frequently come up in my classes. The idea of ancestry testing is you use genetic data and evolutionary concepts to determine your genetic heritage. For example, how much of your genetic material is Irish? Or are you related to a famous person? Things like that. Does ancestry testing have a practical importance? It might seem like it has a practical importance because it impacts people's perceptions of their identity. But we're stretching the term practical here. There are some approaches to medicine where knowing a patient's recent geographic ancestry could be important. For example, if much of your recent ancestry was from Central Africa, you may want to check to see if you're a genetic carrier for the trait that causes sickle cell anemia. So ancestry testing could be useful, but it's also often misguided, and very frequently its significance is exaggerated. We noted in this class that all life as we know it is consistent with a single common ancestor. This means every person you've met, every skeleton in every coffin, every historical person who has ever lived, from Julius Caesar, Cleopatra, Genghis Khan, the Aztec Emperor Montezuma, everyone is at a minimum your cousin. This extends further to non-humans. All life as we know it is a minimum a cousin. From the duck-billed platypuses to the Venus flytrap, to the flies in the Venus flytrap, to all the creepy crawlies around the Venus flytrap, even down to the bacteria, all of it are your cousins. Very distant cousins, but your cousins. So when you hear in the news that an actor was found to be related to a famous king or emperor, you should not be surprised because you're also related to that king or emperor. That said, it's exciting to hear when you have a famous direct ancestor. In other words, not a cousin, but a grandparent or a great-grandparent, etc. We are all guaranteed to have some interesting grandparents, but unfortunately a lack of historical information prevents us from telling their stories. But here's one that applies to probably everyone watching this. Around 200 to 160,000 years ago is the approximate time in which everyone in the world today converges to a common ancestor. But from 200 to 20,000 years ago, there was more than one type of human walking around in the world. Most of our ancestors at that time were what we call today anatomically modern humans, otherwise known as Homo sapiens sapien. This is the same species and subspecies as you and me, everyone. But to be fair, even though we call ourselves Homo sapiens sapien, the vast majority of us, most likely all of us, also have ancestry to non-anatomically modern people, otherwise known as archaic humans, such as the Neanderthals. It's quite obvious that these admixture events with Neanderthals were happening even 35 to 40,000 years ago. Thus, in all likelihood, one of your prehistoric grandparents was an archaic human. What we find is that some areas of the human genome have diversity much greater than you would expect from a common ancestor 200 to 160,000 years ago. And as a result, this implicates an event in which archaic humans contributed to our gene pool. Interestingly, some areas of the genome that have been implicated by this admixture are also involved in our autoimmune system. It's hard to imagine that this is coincidental. A current hypothesis is that this contribution to our autoimmune system was adaptive and allowed otherwise anatomically modern humans to resist disease as they began peopling the world. Remember, humans today have very little diversity overall. Ways to obtain diversity, such as interbreeding with archaics, could have certainly been adaptive. Maintaining diversity in our autoimmune system is clearly important for fighting off diseases. Species that are very inbred are highly susceptible to infections. Most of us see this today. A specialized interbreeding of dogs and horses and many domesticated plants lead these domesticates to be very vulnerable to infections. This connects back to our earlier discussion of trying to breed superhumans. Maybe we could breed a human thoroughbred population for a specific task, but the next avian flu might just wipe them all out. So thousands of years ago, anatomically modern humans who interbred with archaics could have had a distinct reproductive advantage over those anatomically modern humans who didn't. And these admixed individuals appear to be our direct ancestors. Thus, it appears that everyone today has an archaic grandparent. There's still a chance that there are people today that are an exception, maybe in parts of Africa, but I wouldn't bet on it. Understanding the aspect of the human genome that has archaic contributions can provide information about natural selection. There may be archaic alleles out there today that provide valuable contributions to disease resistance.